This is a demonstration of Face Forensics' unique F2 tattoo recognition software. While I'll refer to images as tattoos for simplicity, they can also be scars and marks. Let me start by showing you what it can do. You're looking here at the main F2 screen. This is where you can connect to an existing database of tattoos and then match other tattoos against them. The blue area on the right is where we can drop in a probe image of a tattoo that we want to identify, while the black area on the left is where the top matches will appear. So let's see it in action. I'll drop in a tattoo, in this case of a unicorn. The distinguishing characteristics of the image, i.e. the intersection of different lines, curves, areas of colour and so on, will automatically be found and encoded mathematically into a unique numeric string. When I click the recognition button at the bottom, F2 will compare this string with the strings of each of the 5,700 tattoos in the database that we're connected to, sort the results into match percentage order, and display them as thumbnail images on the left, together with the match percentages and the name or record ID of the owners. The result in this case is 3 matches above the recognition threshold, i.e. there are 3 different shots of this tattoo in the database. The probe and a selected database image can be compared side by side and magnified using the scroll wheel on the mouse for closer inspection. Just pull that over and I can expand and enlarge each image. We can also link back to the full record of the owner in the original database. Depending on where we set the recognition threshold, non-matching images may also be displayed further down the match list. Let me show you. If I reduce the threshold here by just a few points down to, let's say, 92.2%, and then click the recognition button again, this image comes up. Non-matches like this have characteristics which are similar to the probe image, although visually they may look quite different. When you look at them in detail, you can see areas of similarity. For example, the angle of the legs here and of the leaf here, and also of the curve on the hind leg of the unicorn there and on the back of the beetle there. These features also have similar relative positioning. These non-matches don't really matter. When officers look at them, they'll ignore visually dissimilar matches anyway, and they have what they're looking for with the top matches. So the benefit is that instead of having to look through many thousands of images, officers only have to look at the top result and those close to it to confirm a match. The tattoo images in the database we're searching are very largely provided by the National Technological University in Singapore, to whom we offer our thanks. The database includes numeric record IDs, but not names. Clicking on the Tattoo DB tab displays the individual tattoos in the database. I can scroll through them using the control at the bottom of the screen. When F2 is first connected to an existing database containing tattoos, the Enroll All button here is used to automatically enroll every image in it. If images are in a folder, they can be automatically imported and enrolled separately. After this, they're ready to be searched. Search speeds can be thousands of tattoos per second, depending on the hardware configuration. For large databases, the search can be spread across multiple processors. Incidentally, the match percentages themselves are not on a linear scale. Anything above 92% is generally a match, while below around 88% is generally not a match. So let's go back to the search window and look at a different example. Unlike face recognition, where the face is assumed to be vertical, shots of tattoos can be taken at different angles. Here's an example. It's a neck tattoo. When we click on the recognition button, you can see that the single image that it matches against is at around a 35-degree rotational difference to the probe, but nonetheless it still matches at the top of the list. In many cases, a tattoo can be partially hidden, for example by clothing. Here's another example of this, and I'm going to add to the complexity by combining it with a further challenge, handling the blurriness that can happen when tattoos get older. When I drop the probe image in and click the Recognize button, you can see that it's a partial shot of a larger, nondescript tattoo. The system really has nothing much to work with, but it still finds the single correct match out of 5,700. I mentioned at the start that F2 can match scars and marks as well as tattoos. This is a further challenge as they're generally much smaller than tattoos and contain much less detail. Here's an example of a scar. As you can see, it's mostly plain skin, while the scar itself is quite small with no sharp edges. Nonetheless, F2 can still find it as the top match against the database. When a new tattoo is added to the external database, the system will automatically detect this, encode it, and add the resulting numeric string to its own internal database. This means that searches will always be made on the up-to-date database. So you can see that automated tattoo recognition poses major technical challenges, which is why hardly any such systems are available. Encoding a tattoo is complex because it can be an image of just about anything, it can be at different angles rather than just upright, it can be of any size, and it can be anywhere in the image. As a result, the image encoding and matching process is highly processor intensive. For very large databases, searches can be spread across multiple processors. The system's designed to map onto existing images in Oracle, SQL Server, and DB2 databases. Where the images are in a folder, they can be automatically imported and enrolled into a database. F2 doesn't hold any images itself unless specifically set up to do so, and there's no limit to the number of tattoo images in the database. Different tattoo databases on a network can be searched under appropriate controls. The software runs under Windows 10 and is available as an application, as a .NET SDK, and as a web service. The tattoo module is part of the F2 image recognition suite, which includes face recognition, partial face recognition, corpse identification, and scene recognition. They can be used separately or together. If you're a government agency or an established supplier to them, you can easily test it with your own images in your own environment at no charge, with full online support. We'd welcome the opportunity to show you what it can do.